Hi, and welcome to my project presentation on computer vision enhanced spectroscopy for glucose prediction through an in vitro validation study. Regular techniques to measure glucose in the blood can be very invasive and cause harm to the skin, such as burn marks due to CGMs or finger pricking eventually can cause scarring on the fingertips. So glucometers are not the best option either, in addition to the waste that we get, as well as the lower adherence rate, because these methods can be very painful for users. Research questions include whether can machine learning and models accurately predict the glucose levels in the blood with using infrared imaging data. And the second question is which among the following wavelengths gives us the optimal glucose detection levels? And finally, whether these predictions fall within the clinically acceptable and accurate ranges according to the Clarke Error Grid. So to prepare the data set, we prepared 25 samples, and then we did another 25 samples. The first one using blood concentrate to dye the saline distilled water, and then the proxyon red powder for the second category. So this was to imitate the effects, the chromatic effects of the human blood. And then we created a 3D design to hold the cuvette, and then a synthetic silicone skin to imitate how a potential finger could look like. And then we have an infrared camera on one side and then the laser beam or LED source on the other side. The circuit design consists of a Raspberry Pi that provides a 3.3 voltage that connects to a resistor, a Zener diode for voltage regulation, and finally the light source, whether it's LED or lasers. So the main models that we've found to be useful for such task is convolutional neural networks and AdaBoost with k-neighbors. With CNNs, we were able to get a better accuracy for the 850 nanometer laser with a percent error reaching 11%. On the right-hand side here, we have the Clarke Error Grid for, first of all, the LED with 850 nanometer, then the laser of 850 nanometer, followed by the 805, and finally the 650. And we can see that, for instance, the laser of 850 produced an 87.5% clinically accurate results. So I would like at the end to acknowledge a lot of people for this research, starting with Sophie Brubaker for taking care of the samples preparation, Amy and Isabel for providing us the essential support to access the lab apparatus to make the samples, and my advisor, Dr. Maria Valero, for all her insights throughout this project. Thank you very much for your attention. Goodbye.